Hello everyone, this is Dr. E, and for today we're going to be working on another theorem that we can use to prove that triangles are indeed congruent. We know that writing two-column proofs may be a little bit challenging for most of us, but we also know that learning the skill of writing proofs will help us to think critically and analytically, which is essential when we are working with problems involving math similar to what we are doing today. So the next postulates or theorem that we're going to be using for today is called the CPCTC, or corresponding parts of congruent triangles are congruent, and this is what we're going to be adding to the lists of theorems and postulates that we have used in the past to prove that two triangles are indeed congruent. So let's have this first figure that we are working on, which is this particular quadrilateral with a bisector. And the first thing that we need to do whenever we are writing proofs similar to this one is to always draw the figure. So this is one of my best practices, or what I normally do when I am writing my two-column proofs in geometry, because when I draw the figure, I get more familiar with the shape and I can plan my strategy on how I'll be able to prove that angle 1 is congruent to angle 2. And what is angle 1 right here? This is 1 and this is 2. And we need to prove that they are congruent based on the given information that AB bisects CAD, and CBD. So those are the two, CAD and CBD. So those are the two angles that we're going to be using to start our proof. So let's start with, of course, the two-column proof. So this is our statement. And this is our reason. And for the first one, we know that we can use this information that AB, this line segment, or line, or ray, bisects CAD. And this is in our given information. So we can say that ray AB bisects angle CAD. And the reason, it's our given information. And by having this in mind, that we know that this bisects CAD, using the definition of the angle bisector, we know that this angle is congruent to this angle. So we can write that angle CAB is congruent to angle BAD. Angle BAD. And this is our second statement, and we know that because of the definition of angle bisector. So that is our second line, and since we are able to establish the second line, which is because of our angle bisector, we know that these two angles are congruent, and we named it as CAB because we have a vertex of A right here with our angle that we have shown right here. And the next thing that we can share is that we can focus our attention in our bisector. So we can say that this bisector is also bisecting CBD. So we know that AB or BA, we can interchange them, bisect angle CBD. And we know that because it's the given information. And by using this information, we are now able to share that this angle is also congruent to this angle because that is the definition of an angle bisector. So let's add that in our statement, and we are going to name this as CBA, angle CBA, is congruent to angle ABD. ABD. So we know that this is true because this is a definition of angle bisector, because this angle is being bisected by line segment AB, CBA, and DBA, or ABD. It doesn't matter as long as our vertical angle is in the middle. So now that we have proven that, let's share that this is common to triangle CAB and triangle DAB. And to be able to do that, we need to use AB or BA congruent to line segment AB using the reflexive property. And by doing this, we're able to share that we have A as a postulate that we can use to prove that we have a congruent triangle. So this, we know, is triangle CBA. CBA is congruent to triangle DBA. Triangle DBA using the A as a postulate. And by doing this, using the third angle theorem, or also CPCTC, because they are all corresponding, or these two corresponding angles are congruent, so the last angle is also congruent, now we can show that angle 1 is indeed congruent to angle 2, and we can use CPCTC because we're able to establish the congruent parts or the corresponding parts of these two triangles to be congruent, and we're able to finish our proof similar to what we have. So this is how we use the CPCTC theorem to show that angle 1 is congruent to angle 2. So this is where we continued. We know that CBD has been bisected by this line segment. So we now have a congruent angle, which is CBA and ABD. And using our reflexive property, we'll be able to establish the congruency of the longest side of the two triangles, and we're able to prove that the two triangles are congruent using A as a postulate. And now that we are able to show that the corresponding parts of the two triangles are congruent, we can now use this reason to show that angle 1 and angle 2 is indeed congruent because of the CPCTC theorem. And that is how we use this theorem in proving congruency with two triangles. So with that in mind, how are you going to show that RS is congruent to RL given this particular diagram with ship, a lighthouse, and a tree? So we know that TRS, or angle TRS and TRL, are right angles, and RTS is congruent to RTL. So using your skill in writing two-column proof, comment down below and let's see how you're going to articulate your proof in proving RS is congruent to RL. So this is our lesson on CPCTC, and we know that it's challenging to work or articulate our two-column proofs, but with practice and understanding on why these theorems and postulates work in the diagram that we are working in geometry, it will be a lot easier the more that we practice how to prove figures similar to what we did today in geometry. This is Dr. E, and see you again next time. Bye!